assignment tomorrow on graphing. So I'm going to review this with you a little bit today. We're going to use the question on page 69 to show you how to do it. When you are graphing, you can take from a velocity time graph, you can create an acceleration time graph, and you can create a distance time graph from the velocity time graph. Okay? Now from a distance time graph or position time graph, you can only go to a velocity time graph. Alright, from an acceleration time graph, you can only go to a velocity time graph. But if you start as a velocity time graph, you can go to both ends of it. So what we're going to do right now is we're going to look at how we got to approach this question and how we draw both graphs from it. So, it says from the VT graph, draw the corresponding DT graph and AT graph that goes with it. Okay, so the first thing I suggest you do is have a chart made for the original graph and write down the information that we have on the original graph. So I'm going to label my 5 sections, A, B, C, D, and E. Okay? And I'm going to write out my, let's start with displacement or position. I can do my, actually I'll start with velocity because it's already on there. Let's do velocity, time, displacement, acceleration. Okay. Alright, so the velocity in the first interval, how fast is it going after 2 seconds?
15.
Sure, 15 meters per second. Okay, let's just focus on those two for right now. In B, how fast is it going and for how long? 15 meters per second for 3 seconds. Agreed?
Yeah.
Okay. In C, it's going from, what's my change in velocity here? Louder? What's my change in velocity here? What's it starting at?
15.
15 and it's going to? Negative 15. So what's my change in velocity here? Right. So it's got a change in velocity of minus 30 meters per second. And how long does it take to do that? 4 seconds. Okay. In D, it's going how fast? Negative 15 meters per second, and for how long? 2 seconds. And then my change in velocity in the last interval is 15 meters per second, and how long?
1 second.
1 second. Okay. So far, so good. All right. Now, quick question. What's my velocity average?
0.
0. How come?
Because your displacement will change.
Because I started and I finished at the same spot, right? So my velocity average in that case would still be 0. Now, that's if I use the velocities to do it. But we don't want to use the velocities. We want to use the displacements to find the velocity average. So we're not going to use that. Okay? Those are just set up there just for information to get those two on the bottom. All right. So first things first. This is where we actually have to solve some things. Okay? So, what's the displacement under the graph for the first 2 seconds? How do I find how far he went in the first 2 seconds? 15 times 2 divided by 2. It's a triangle, so you need to find that area. So that works out to 15 meters. in the positive direction. From 2 seconds to 5 seconds, how far does he go?
Then you go 15 times
45 meters.
45 meters. Still in the positive direction. Right? I've got to break this next one up a little bit. Okay? Because I start going, I'm still going in the positive direction, but then I end up going back in the opposite direction part way. So from 5 seconds to 7 seconds, okay, he goes 15 meters again in the positive direction. Okay, so I'm working from 5 seconds to 7 seconds. Then from 7 seconds to 9 seconds, it's going 15 meters in the opposite direction. Pardon me?
They just cancel.
No, we're not. No. Yes and no. I'm going to show you how this works. When I draw it, it'll make more sense, okay? So now, the D part, I'm going negative 15 meters per second for 2 seconds. So how far does he travel? I'm still on the opposite side of it, so it's negative 30 meters. And 15 meters for 1 second, but again, still on the other side of the line, which means he's going in the opposite direction that he started going. So that is negative 15 meters, no, 7.5 meters per second, right? Negative 7.5 meters, sorry, not meters per second. Meters. Yes. Okay, so first things first, the question that Lexi just asked is it still negative because it's under the line? And the answer, of course, is yes. So when you're looking at it in the textbook, when you're finding the area under the graph, all of this is in the positive, anything below that line is in the negative, which just means you're going in the opposite direction. Even though the speed's increasing here, all right, you're still going in the opposite direction because you're below the line. Don't make that error. It has to stay that way. Okay? So now, what I'm going to do next is I'm going to draw this out. So does everybody have this written down?
No.
Why not? Great. Who has it written down? Okay, perfect. You're going to help me, Bodie. Only one that's doing this. It's on the board, it needs to be written down.
Well, lots of times how to look.
All right, so here's what's going to happen. 2, 4, 6, 8, 10. Okay, so Bodie, first 2 seconds, how far did he go?
15 meters.
So I'm going to go like this. 75, I think, as far as it goes. So there's 5, 10, 15. Okay, first 2 seconds goes 15 meters. Okay, it doesn't have to be a straight line here. All right? From 2 seconds to 5 seconds, how far does he go?
Another 45 meters.
Another 45 meters. So how far after will he be going? So that's after 5 seconds. He'll be going 60 meters per second, so up to here. Okay, and then
15 and
Another-
negative 15.
another 15 meters. So at 7 seconds, he's now how far from where he started?
7,
He's at 75 meters from where he started. Now what happens? He starts to come back towards himself, right?
Mhm.
So another 2 seconds, and he ends up
Negative 30.
ne-
Or like minus 30. American was,
Is that interval minus 30 or minus 15? It's minus
or
15.
minus 15, sorry.
Right, minus 15. So at 9 seconds, he's back to 60 again. Agreed? Okay? And then
And minus 30.
minus 30, so that takes him down to 30 seconds, or 30 meters at 11 seconds. So he's at 30 now, and then what?
7.5.
7.5. And that's at 12 seconds. So he's at, okay. Did he come all the way back to where he started?
No.
Where is he? What is it?
22.5.
That's right. He's 22.5 meters short of where he started. Okay? So, now when I ask you what the average velocity is for that trip, you have to take your displacement and divide it by your time. Okay? So I do not use velocities to find my average velocity. I use displacement and time to find it. So 22.5 divided by 12. Its average velocity for this trip was 8.75 meters, and I'm going to just put it in the positive direction because he stayed on that side of it. So that is drawing a DT graph, a distance time graph, from a velocity time graph. All right? Any questions? Again, velocity average is displacement over time for that interval. In this case, from here to where he starts. So that is 1.875 in the positive. Okay? Now, we're going to go back to here. Now I want to do acceleration time. Okay? Now how do I work an acceleration time graph from a velocity time graph? Well, what is acceleration equal to? Velocity over time. Change in velocity over change in time. That is change in y over change in x. So how do I get the acceleration from a velocity time graph? What do you think I'm looking for? Well, we found the displacement already. I want to find acceleration from a velocity time graph. How do I get it?
Divide your velocity by your time.
But from the graph, how do I do it? What am I looking for? That's time, that's displacement. Okay, let me pose the question a different way to you. I had a position time graph, D and T. How did I get the velocity from it?
The distance divided by the time.
Yeah, but from the graph, how did I get it?
Area.
Nope,
So the area.
nope.
You broke it up.
D equal V2 over A T.
No, you're not using equations. I need to know from the graph. If I gave you a displacement time graph, how did I get it? How did I get the velocity? Alright? I'm not giving you the answer to this. Here's a displacement in meters. Here's my time in seconds. Right? How did I get my velocity from there? What is that called on a graph?
Slope.
Slope. Slope. The slope of the line gave me the velocity time. Agreed? Because the velocity is displacement over time. Now, I'm trying to get the acceleration from this velocity time graph. So how do I get it? Slope. It's velocity over time. So what's the slope in the first interval? What's the slope in the first interval? 15 over 2. 7.5 meters per second squared. What's the acceleration in the second part? In B?
5 meters per second squared.
0, 3.
Okay, what are you seeing? Look at that graph on your piece of paper right now. What is the object doing in section B?
Uniform
It's
velocity.
zero, there's no change in velocity.
It's what?
Uniform.
So therefore,
Zero.
0 meters per second squared. Why? Because it's uniform velocity. It's going at a constant speed. So if something's moving at a constant speed, is it accelerating or decelerating? No. No, it's not. All right? What's the acceleration in part C now? What's the change in velocity? Negative 30 meters per second. How long does it take? 4 seconds. So what's 30 divided by 4?
Negative 7.5.
That's right. Negative 7.5 meters per second squared. Good. All right, how about D now? 0. How come? So it's uniform. It's going at a constant speed. And then in E, what's happening in E? 15 meters per second squared. 15 divided by 1. Negative 15 divided by 2? No, because it's going at a constant speed for that. This changes from 30 to that. Okay? There's my acceleration now. So using this, I'm going to create an acceleration time graph. All right. What was the acceleration in the first interval?
7.5.
7.5. So here's the difference now. My acceleration, I'm going to draw it like this, straight across, because it's constant. Okay? From 2 to 5 was what?
0.
0. So I draw it down like this and go across to here. Because it's going 0. From 5 to 9, it's what? Negative 7.5. So I go down to negative 7.5. I come all the way across to here, up to 9. From 9 to 11, it is 0. And from 11 to 12, what is it? 15.
So you always come back down.
Acceleration in meters per second squared. No, not necessarily. Time in seconds. If you look at page 69 and you look at the middle one that they show in the margin, okay, look at the acceleration on it. if it just changes, the reason I go back to 0, this one I'd probably leave like this actually, Roy. I'd be done with that. Just leave it there. Okay?
So if
The
you-
reason these guys are coming back down is because they go to 0 at that point.
Yeah, they're going to 0, but. Okay, that
So if let's say hypothetically, the next one was 7.5, I would just go like this,
one- Okay.
okay?
Makes sense.
It's just that I have to go to 0 for those ones. All right? Okay, so first thing that we had to do was create our chart. Find all of the intervals, find the information. Now again, this all comes from a velocity time graph. The only way you can get to a distance time graph is from a velocity time graph. The only way you can get to an acceleration time graph is from a velocity time graph. Okay? So, that page, I did the question, the practice question on that page, that's page 69. There is one in the margin that it shows you how to do each interval and what it's looking for. So, if you haven't done much of this graphing, you need to do it now.
So wait, these graphs they have on the side is for the same question?
Sorry?
The graphs that they have on the side here for the same
No,
question?
the graphs on the side start with the middle graph in the margin.
Yeah.
And it goes dt and at from the middle graph. This is just an example. So this goes to here and this goes to here. This has nothing to do with any
Oh,
of this.
okay.
Okay? All right, so tomorrow I'm looking at giving you an assignment on this. That would be a hand in for marks. Okay? And then you have, today, you have review questions that you can hammer out that I handed out to you on Thursday. So you've got all of those questions to do. There are more graphing questions in the book. If you in the review, those might be your focus today. So like questions on 10, question 18, question 20, 21, 22. Some of those questions in the book there.
Would that be in our review?
They're in your review. Those are all questions that will help you for tomorrow.
Those are like graphing ones.
Yeah. Okay? So that might be your focus today, would be on your graphing questions in your review. And then after we write the assignment tomorrow, you can go back to doing all the questions that work with the formulas. All right? Any questions, concerns?
So if we're having an assignment on this tomorrow, are we doing a test this week too?
Possibly Friday. We'll see.
What on Friday?
A test possibly, we'll see how this goes though. Okay? So it's not Friday, it'll be early next week. All right, any questions, other questions today?
Can we do one on the board?
Sure. Whereabouts?
On the review, page 79, number 7.
No. This one, we got one. I told you to leave that out. Yeah. Well, when you, after tomorrow, I'll do that one on the board with you. But for right now, it's not something that you need to have done. Okay? I don't test you on it either, but I'll show you how to do the question. Okay, any other questions today? Okay. Good work then.